All right, kids, we're going to do section 831, question 53. If you read the question, you have a small triangular pennant that's 1 foot by 1.5 feet tall. And the next one is 3 feet tall. So how wide would the new larger triangle need to be? Well, since they're similar triangles, to go from 1.5 to 3 is double. So you got to double the width. So the new width is, you guessed it, 2 feet. That little right there, that means feet. So that's the same thing as saying 2 feet. Okay, the next question says, if the smaller pennant costs $2, how much would the bigger one? And most of you are probably thinking, well, just double up the cost, so it would be $4. But you will see here in a second that that is not the case. So let me zoom in just a touch. All right, let's find the area of each triangle, and then we'll figure this out. Well, if I have the small triangle, it told us that it's 1 foot wide by 1.5 feet tall. So remember the formula? A equals 1/2 base times height for a triangle. A equals 1/2, base is 1, height is 1.5. You pop that in the calculator. See, half of 1 is 0.5, and 0.5 times 1.5, 0.75 feet squared. Well, let's find the bigger one. Well, the bigger one had a base of 2 and a height of 3. So again, the formula 1/2, the base is 2, the height is 3. You run that into the calculator and you will get 3 feet squared. As you could see, it is not twice as big. As a matter of fact, right here, this is how many times bigger? Well, if you took 3 divided by 0.75, it is going to be actually 4 times bigger. Okay, so what does that mean? How much would we have to spend then on that other one? Not $4. See, we had $4 here. We would have had to spend 4 times 2, which is $8. So here, let me just put it in a nutshell for you. For letter D, to find the new area, you take the scale factor and square it, and you will have 4 times the amount of area. What if the scale factor was 3? How much more area? Well, 3 squared is 9. Okay, so on and so forth. What if we had, let's do one more. If the scale factor is 4 times as big, you have 16 times the area. So in a nutshell, let's do here. Okay. For the perimeters, this is the impact it's going to have. The new perimeter, I'll call it P, is equal to the scale factor times the original perimeter. Okay, so the perimeter goes up in proportion, just whatever the scale factor is. However, the areas, that is not the case. Okay, the new area, I'll call it A, is equal to the scale factor squared times the original area. That's pretty much the impact that a scale factor will have on perimeter and area of a shape. Take a break.